Good evening, everyone. I request Kevin sir to start the session.
Good evening, Brenda.
Good evening, sir.
Audible to you? Sense?
Good evening, sir. How are you, sir?
Slightly better. Yes, students. Thank you, Vignesh. I'm slowly getting better. So begin our today's class. Just now I'll share the PDF. So as I informed yesterday, please, if you're taking screenshot, don't share the screenshot anywhere. Hmm. And that screenshot, I'm sharing that screen only for your convenience, so that uh, you take the screenshot and write it in the notes. As I'm informed earlier yesterday, please don't share it anywhere else. If that's the case, I'll stop sharing that one. Instead, I'll use the white screen. Because you have to keep on writing whatever I am telling afterwards. So yesterday we were discussing about the area of triangles. Isn't it? Yesterday we were discussing the area of triangles. We finished found by the forum area of a triangle, area of a rhombus, then area of a triangle by three different lengths, not at the origin, but rather in different forms. Now we'll continue the same topic. Area of a, okay, this also we discussed. Area of a triangle with y is ymx plus c, y is equal to mx plus c lines. Now we'll go to the next of this one. Area of a parallelogram. Area of a parallelogram. That is what they're telling is, listen carefully. That is the point number 11 they're telling. If my parallelogram, let us say if this is my parallelogram, the parallel distance, if I take this parallel distance as P1, parallel distance of these two lines, and these two lines parallel distance, that is this distance, if I take P2, then the area of a parallelogram is given by A is equal to P1 P2 whole divided by sine theta, of course within the modulus. So area of parallelogram is given by distance between the two parallel lines. Of course, when we say parallelogram, that means there are two lines are parallel. These two lines are parallel. These two lines are parallel. So those P2 is multiplied by the, what is this angle theta? Theta is the adjacent angle of angle between the two adjacent sides. If this is my one side and this is these are non-parallel sides. This side is non-parallel, this side is non-parallel. The angle between two adjacent non-parallel side is taken as theta. The angle between two non-parallel adjacent side is taken as theta. Then in that case, area of parallelogram is given by A is equal to P modulus of P1 into P2 by sine theta. Now we'll take the area of parallelogram, which is formed by four different lines. Here, when the distance is given, we are doing. Now, instead of giving distance, they're giving you. Excuse me. Here, instead of what is this called as instead of the distance of two parallel lines, they're giving you the four different sides of parallelogram in the equation. This side, this side, this side, this side. sides. Then how to find the modulus of T1 minus C2 into D1, very important formula. Often we'll be using to solve this problem. Not only in this 2D geometry, but also in 3D also we'll be using this concept. So is it clear, dear students, the area of different quadrilaterals? We discussed today about the area of parallelogram. Of course, there is one more we'll be discussing, area of rhombus. Here, area of rhombus. And when they give the distance between, that means the length of the diagonal. So rhombus, you know how rhombus is formed, no? For example, if this is the rhombus formed, means the length of this diagonal's length and this diagonal's length, if they give, then the area of rhombus is given by half into D1 into D2. What is my D1 into D1? D2. D1 is one of my length of the rhombus, and D2 is another length of the rhombus. Length of the diagonal of the rhombus. This one, D1 and D2. So when the length of the rhombus is given, last time we saw when the equation of the rhombus is given, 2 into C square by mod of AB. And A mod x plus B mod y plus C is equal to 0. And that is given. We learned that area of rhombus is 2C square by mod of AB. Now, instead of this one, what is this called as? Instead of the equation of the line, they are giving you the what is this called as? Line equations of rhombus. So distances, instead of line equation, they are giving you the diagonal length. Then the area of the rhombus is given by half into D1 into D2. See, this is they're asking us to find the area of the triangle. The ratio of the lines they're asking us to find here. Last time we ran that formula, no? Basing on that one, they given 3 sides of a triangle. These three lines are forming. What is the ratio? That is one question, one note question, example question they're giving. This is to find whether it is okay. This will solve when we come to problems. We'll solve. Now, before going to foot and image, I want to discuss regarding one topic. That is number of lines of triangles and circles that I discuss. Then we'll go to triangle. Then we'll come back to foot and image. Should be this lines of triangle, number of lines of triangle. Okay. This is a very important topic. Sometimes you can get as a individual multiple choice question, or you can get as a assertion reason, or you can get it as a multiple choice also. How many lines or how many triangles, how many circles can be drawn within a given condition? The first thing, number of lines drawn to the point A, which are a distance different. Means this is point A. Let us say this is point A, and point B. From A to B, circles can we draw from point A Now, how many lines we can draw through A? Through A means the line has to pass through A from B. From B, how many lines I can draw to A? When the distance is D between them. That's what they're telling. If the distance between AB is D, then only one line can be drawn through A from B. Means from B I can draw only one line like this through A. If my distance of AB, my distance of AB is greater than D, let us say D is some 3 units and this distance is 5 means I can draw two lines. I can draw two lines. That is the condition given here. If AB is greater than D, then the number of lines drawn through A at a distance D from B. From B through A, I can draw two lines. If my distance of AB is less than D, the number of if my AB distance is less than D, then I can't draw any line from B to A. I can't draw any line from B to A. This is with regard to straight lines. Now let us come to triangles. How many triangles we can draw? Especially with regard to straight lines, not much question will come. With regard to triangles and circles, lot of questions will come. Please listen this topic. So, how many right angle triangle can inscribe a circle? Let us say, this is my circle. How many right angle triangle I can inscribe in a circle? That is what the thing is. So, to inscribe a right angle triangle in a circle, what is at most important or what factor depends a lot is the height, the altitude of the triangle and the radius of the circle. That is, if this is my right angle triangle, this altitude plays a very important role. With that, the circle's radius plays a very important role. So, basing on that only, we can inscribe a right angle in a triangle. So, basing on that one, let us see how many right angle triangles we can. If my h is equal to r, means my height of the right angle triangle and my radius are both same, then we can inscribe two right angle triangles. That is, the circle is like this, and if the radius is equal to h, both are same. Means I can inscribe here. I can inscribe two right angle triangles. Yes, I can. They not be like this. So if h is greater than r, means if my height of the triangle is greater than r, that is sorry, what I draw is wrong. If this is h means, then right angle triangle means just a minute. I can draw two right angle triangles like that. So coming to the second concept, if my h is less than r, that means if my height of the triangle is less than r, I can draw four triangles. Because radius is big, height is small, so I can draw four triangles. By chance, if my triangle's height is more and radius is less, I can't draw not even a single right angle triangle in a circle. I can't draw any right angle triangle in a circle. Very often these questions come as a multiple choice question, like sub questions. So sometimes we take it for granted. Oh, these things are very silly. Sometimes these things can play. Now, next thing is how many circles we can draw by touching three lines. If three lines are given, how many circles we can draw by touching these three lines? if two lines are parallel, let us say in 3 lines, let us say in 3 lines, if 2 lines are parallel, we can't draw a circle. No, miss, we can't draw any circle touching these 3 lines. That means the circle will touch only these 2 lines. This will not touch the third line. Therefore, in this condition, we can't draw a circle which touches all the 3 lines. If the lines are concurrent, means if the lines are meeting at some point, then we can draw at least one circle. Maybe if there's a concurrent, means they are meeting at one point, we can draw a circle, number of circles touching 3 lines. One circle that I'll show in the next time. I'll show in the diagram. So it is difficult to draw without any help of compass, pencil, and so on. And that too in this screen, it is little very difficult to write also. Just now I told this one. No? If 2 lines are parallel and one line cutting the third, this one. Let us say if it's not like that. So now in this case, I can draw 2 circles. One circle like this, one circle like this. We call like this. We come. This will study 2 lines cut by one line. That concept will study in the next chapter. Transversal, all those things. Parallax, transversal, all those things will study in the next chapter. A pair of lines. No lines are concurrent, means no lines are parallel, no lines are concurrent, then we can draw 4 circles. If 2 lines are parallel, we can't draw any circles, 0 circles. If lines are concurrent, we will draw only 1 circle. If 2 lines are parallel and one line is cutting them off, then we can draw 2 circles. If all the 3 lines are non-concurrent, non-parallel, they are not even concurrent, they are not even parallel, then we can draw 4 circles. The number of lines we can draw through a point, number of right angle triangles can be inscribed in a circle. Number of circles drawn touching the 3 lines. So is this concept clear? If it's clear, we'll go to the next topic. Say something, you can text. You can put in a chat box also. I can access to your chats. If it's clear, just give an S. If it's not clear, just say which topic is not clear. We'll repeat it. Students can respond. Silence sometimes confuses me whether you are understood or not. And
Yeah.
another one doubt I get is whether you are listening to class or not. So the silence either through chat or through unmuting the mic. If it is clear, pardon? Hello. Yes. Okay. Gayatri has told us, sir. Then others also okay. Go to the next topic. Bhavana. Over there. Let's see. Okay, there are some new faces. Now Neet is new. Sophian is new. Then Shravani, no response from any days. You are attending the class, but not even responding. If it is okay, we'll go to the next topic. Is it okay? Shall we go to the next topic? Hello.
Yes, sir.
Okay. Now, very
Yes.
important topic will go on. We'll go on to a topic of footprint image. This topic is not only important in 2D geometry, but also important in 3D geometry. Same concept will be using, but here they will be using with vectors and other things. But all the conceptual things, all the things are same. But for this, I'll share the other screen because I have to draw certain things I have to show. Just I'll stop sharing this one. I will go for the sharing the normal screen. Because I have to draw a few things and explain to you.
Sir, will you send PDF of that screen shared?
No, extremely sorry, no. I have told you very clearly the reason why I am presenting is either you take note of it, or else take screenshot of it. Because that is material from our academy and we are instructed not to share it. Instead, I am sharing it because the theory part of it is very deep compared to other this one. So only I am using our academy's theory concept from our book. I have told you very clearly the reason why I am presenting the PDF of our academy. A minute.
Okay, sir.
So please, at the beginning itself, I told you, don't expect me to share any notes. And all the more if I'm sharing something, please, don't. Share yourself. If you are feeling free, you can take screenshot, but not to share the screenshot with anybody. But you have to write it after the notes. I told you very clearly yesterday itself. Please, in this regard, I can't help out. I will not share that one. Now we will come up the concept of foot of a perpendicular and image of a point. Image of a point. Very important topic, both also. First, we'll discuss what is foot of the perpendicular or perpendicular distance, all those things. Then we will go to this concept. Now, let us say some of these things we also discussed in basics of 2D geometry. Now, this is my x and y axis, and there is one line here. There is one line. Ax plus by plus c is equal to 0. Then there is one point somewhere here. P x y. This we have discussed. This we have discussed now also. We have discussed. This we have discussed earlier also. Basically, we discussed theorems also last week. So I got my line ax plus by plus c is equal to 0, and I got my point. Now I have to find the distance of this point. How do I find the distance of this point to my line? Students, how do I find the distance from this point to the line? Students, at least respond if you don't know, sir, don't know, sir, forgotten. Huh? I think some of you are searching in Google.
Not clear, sir.
Pardon?
Your voice is not clear.
There is a line ax plus by. There's a line ax plus by plus c is equal to 0. And there's a point px comma y as shown in the screen. Now, I need the distance between the point and the line. That this distance. I want this distance. This distance I want. How do I get the distance? The distance from the line to the point, or from the point to the line. How can I get the distance of the point to the line, or from the line to the point? I get out the formula and so on. At least how I can measure it. Okay, leave out all this concept of mathematics, straight lines, and so on. Imagine there is your house, and somewhere there is a adjacent to your nearby house, there is a playground. How do you calculate the exact distance? That's the average distance. This is the line, and this is the point. How to find the distance between that one? That's basic question. I don't know the formula. I don't want the formula of D is equal to and so on. Tell me what you will do to find the distance. Are there students in the meet? Hello. Students are in the meet. Yes, students can I respond? Okay, students. Be in the meet. Yes, students, can I respond? At least say, am I audible to everyone? Yes, am I audible? Dear students, am I audible? Dear students, am I audible? Dear students, am I audible to everyone? Respond, dear students. Hello, dear students, am I audible? Hello.
Yes, sir, you're audible, sir.
So at least respond no, at least yes or no. I'm asking a question. For that also there are silent. I'm asking at least, if not the formula, tell me what method you're going to use or what I told normal thing. Please respond, dear students. If you are quite okay, I myself will explain what to do if you are not willing to answer. So if there is a line, there is a line, a point here. You can measure distance from this point, 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 from this point. You can measure from all these points, but all these distances are different. So to get an accurate distance of the line from the point, what we will do is, last time itself we have done all these things. We derived this one also. We'll consider a perpendicular from the point to the line. This length of the perpendicular will give me the distance of the line to the point. This is the shortest distance a point can have with the line. And the length of the perpendicular. Means when I draw a perpendicular exactly to the line, that length of the perpendicular will give me the shortest distance of the point to the line. That's what we usually do in our everyday life also. If we can, if you want to go from our home to home to the nearby ground, we take the shortest route possible. Nobody is willing to take a road of 2 kilometers compared to a road of 900 meters. Because we all like to take a shortest route possible. Similarly, to get an accurate thing, we take the shortest distance. Now, of course, we will study this concept of shortest distance in the next 3D also. The shortest distance possible is the help of the perpendicular. So only we draw a perpendicular from the point to the line, and that length of the perpendicular give me the distance of the point to the line. Now, see, this is the perpendicular. The perpendicular tip has got a point p x comma y. This down, the end point of this perpendicular meeting the line. This is nothing but the foot of the perpendicular. Let us take it as x dash y dash. Q x dash y dash is nothing but the foot of the perpendicular. Means perpendicular foot. Feet on which the perpendicular is standing. Meeting point of perpendicular on the line. That point is called as the foot of the perpendicular. If this is my line. This is my line. This is my line. And this is my perpendicular. This point Q x dash y dash will be my foot of the perpendicular. Do you understand the concept of foot of the perpendicular now? Hello, dear friends. Do you understand the foot of the perpendicular?
Yes, sir.
Now coming to the concept of image. If px comma y, if px comma y is my point, then its image with respect to x-axis will be here p dash x comma y. The same thing with regard to y-axis will be here p dash x comma y. So the image of point px comma y depends along which line we are taking. The image of px comma y depends on which line we are taking. A very important topic. Whereas perpendicular distance, nothing. Just only a perpendicular distance is required. Foot of the perpendicular is required. There is nothing more than that. But whereas for this one, we need the what is called reference axis or reference line. Which axis it is getting? Through which axis I am getting an image? To get an image, we need even. Let us come to the concept of physics. We are learning the concept of optics and lens, correct? No, there is an object. To get the image of that object, I need a medium. Or else I need some lens, bifocal lens, or a lot of lens are there. Convex lens, and in the convex lens itself, distance is there. Adjacent distance, we are getting different types of images there. That means the image, the light of the image is passing through a convex lens and that's reflection we are getting on the screen. Then concave lens. So that convex lens or concave lens is a reference medium, a medium through which it has to travel. The optical instrument. So here our reference medium or our optical instrument is our axis through which we are getting an image. So we need this concept of image always with reference to some axis, y-axis or x-axis, or a line passing through y is equal to x. That we'll discuss, don't worry. Of course, reflection we already studied in transformation of axis, and we have solved a lot of problems. Just a repetition of it. So this is the basic idea of a foot of the perpendicular, image of a point, reflection of a point. Now we'll go to the some formulas and some theories and so on. First, we'll discuss the concept of image. Image, that is a comma b or x comma y is my point. The image of a comma b with respect to the image of a comma b with respect to y is equal to x axis. That is, if this is my x axis and this is my y axis, there is a line passing through like this. The image of point a comma b with regard to this axis will become what? B comma a. A comma b is my point. The image of this a comma b point with respect to x plus y is equal to 0. This line's image will be minus b comma minus a. Now, if h comma k is the image of h comma k is the image of x1 comma y1. This x1 comma y1 is a point. This point's image is h comma k. To the line, with some line. This image we are getting with the help of a line. Let us say ax plus by plus c is equal to 0. H comma k is the image of the what is this called as H comma k is the image of the point x1 comma y1 with respect to the line x1. Then h minus x1 by a will be is equal to k minus y1 by b equal to minus into 2 into ax1 plus by1 plus c whole divided by a square plus b square. This will be using advanced problems, especially when it comes for match the following questions. When we touch up those problems once again, I'll explain these theory concepts, but you can write it since we're discussing on image and just foot of the perpendicular. This image and foot of the perpendicular is not only important with regard to your IIT or JEE mains or whatever exam you are going to take, CUET or else AICEE, I don't know which exam you are going to attend. Whatever exams you are preparing is not only important for that one, even for your board exam level. Even from the point of view of your board exam level of +1 and +2, it is very important. There will be every year one question based on this one. H or foot of the perpendicular. Sometimes they can ask together. Find the foot of the perpendicular, the image of the this one with respect to this line, that line. So very important topic, not only from the point of view of your entrance exams. Let it be any entrance exam that you are appearing for. And even also it is important from the point of view of your board exams, CBSE. One tragedy what I have observed for many years is students who are doing excelling in IITs and so on have failed to secure 85 plus or 90 plus in a board exam. So I have seen this year also in the beginning of the academic year, there was a huge discussion. We in our department, we had maths department. Students were excelling in JEE mains and JEE advanced and IITs and so on are failing to secure good marks in board exam. That forget about centum. They are not even crossing 80 plus, 85 plus. Come here. Let us leave the topic. Let us focus on what we do. Oh, same thing. If now, let us say, now there is one line Lx plus My plus N is equal to 0. This is a equation of a line in Cartesian form. In 3D we will get one line Lx plus My plus Nz plus C is equal to 0. We get an equation like this. We call this equation of intercept form. Intercept form. Intercept forms equation in Cartesian form. Don't worry, that is same thing they given in 2D form, that's all. Lx plus My plus N is equal to 0. And there is one more equation, Ax plus By plus C is equal to 0, or a normal equation. No general condition. Now, we have to find this line's image with respect to this line. Means there is this line, there is some line Ax plus By, there is one more line somewhat here like this, ALF. This line's image with respect to this line we have to find out. That will be also another, that this line's image will be also another one line only. For example, if we keep a doll in front of a mirror, means the image you will get in the mirror is a doll only. You will not get a teddy bear there. If you keep a teddy bear, you will get only teddy bear, not a Barbie. If you stand in front of mirror, your image will come, not your sister's or your brother's image will come. So only if a straight line is getting a medium with another straight line, and if you want to get an image of this straight line, Image of this straight line will be another straight line only. That means you will get image as another equation only. Earlier you are taking a image of a point px comma y, so you are getting another image as px comma y. Now we are considering a straight line, so another our image will be another straight line only, and that will be a equation. The equation will be in the form of a square plus b square in lx plus my plus n minus 2 into LA plus MB into AX plus BY plus C is equal to 0. This the image of LX plus MY plus NZ, sorry, LX plus MY plus N is equal to 0. This equation's image with respect to AX plus BY plus C is equal to 0 is A square plus B square into LX plus MY plus N minus 2LA plus MB into AX plus BY plus C is equal to 0. Now same thing. Now what is the reflection of this? What is the image of this line? AX plus BY plus C is equal to 0. What is the image of this line with respect to this line? There is one more line now. There is one more line now. LX plus MY plus N is equal to 0. Now I have to find this line's image with respect to this line. It will be of another equation, that is L square plus M square into AX plus BY plus C is equal to 2 into LA plus MB into LM plus NY plus sorry. I'm going back to 3D movie.
Sir, wrong, sir.
Sorry, I told no. LX plus MY plus N. So this is the equation of the image of the AX plus BY plus C with respect to LX plus MY plus N is equal to 0. Is it clear?
Yes, sir, clear.
Now we'll come to the concept of foot of the perpendicular. Perpendicular. If h comma k is the foot of the perpendicular of point px comma y, that is px1 comma y1. This is my point. Of this point, for that is there is one line here like this, and this is my px. This is my p x1 comma y1. That is my px1 comma y1, and this is my foot. This, let us say some q h comma k. This is my foot of the perpendicular. So we are telling h comma k is the foot of the perpendicular of px1 comma y1 of this line. This line equation is given as ax plus by plus c is equal to 0. Then the equation will become as h minus x1 by a is equal to k minus y1 by b is equal to minus of ax1 plus by1 plus c whole divided by root of a square plus b square. This will be a number only, so you can use it. You can do it. Next, we'll be discussing concept on reflection. Already we have done in the next transformation of axis. As a repetition. Reflection of x comma y with the x-axis will be x comma minus y. Sorry. Reflection of x comma y with y-axis is minus x comma y. comma y's reflection with x is equal to y. That will be y comma x. All these things we did a lot of problems in transformation of the equation. You remember when we did general transformation? We did some 3-4 transformations together. That time we did all these things. This is with regard to the foot and image of the what is this called as a point with respect to straight lines. Now I want to start a new topic, centers of triangle. So what I will do is, okay, I want to start, but I will just tell what are the centers of triangle we have. So whatever so far we discussed, I want you to revise and come tomorrow. So I got different centers of triangle is centroid, circumcenter, eccentric, in-center, x-center. How centroid is made up of, sorry, centroid is G, correct, no, sorry, not C. How circumcenter is made, how orthocenter is made, how in-center is made, how eccentric is made. Then circumcircle. So kindly go through this basic thing. We have discussed in basic 2D geometry. We have discussed recently also. When we discussed on concurrency, also we discussed. Medians are concurrent, centroid are concurrent. A lot of that time also discussed what is this median, what is perpendicular bicycle, angular bicycle. So I want you to go through this concept of the centroid, circumcenter, orthocenter, in-center, x-center, circumcircle. Okay, circumcircle we will discuss 2 types. So kindly go through all those topic and come. Then tomorrow we'll discuss a lot of things. Tomorrow a lot of big formulas will learn. And please learn the relationship between G, H and S. Centroid, orthocenter and circumcenter. Relationship between these 3 things. So please brush up all these things and come. Tomorrow we'll be discussing on centers of triangle. We'll be discussing the centers of triangle. With that, we'll discuss some tips or some formulas to solve problems easily. That some extra formulas I will be giving. Once that is done, either tomorrow or day after tomorrow we'll start the problems on straight lines. This chapter is little huge. It will take long time. Don't give up. One of the chapters which makes students very boring is straight lines. That's what I have observed in so far. But don't, because it's a huge also. Lot of things, lot of twisting can be done in the straight lines. That is one thing, especially with regard to straight lines. Compared to circles, pair of circles, all those things, not much is there. But here in this concept of straight lines, lot of twisting can be done, lot of things can be done. So only people skip this chapter sometimes. Only I mean, in the beginning, I'm telling, don't give up. Don't give up. Try till the last. So lot of questions are there. Almost some 300, 400 questions are there. So let us try to solve all those things. Some I will be solving, some I will be asking you to do as a homework. Some of those questions I'll be giving as a test, part of test also. So last topic is the centers of triangle. Once that is done, we'll straight away we'll go to the problems. So please, what we have discussed for 2 weeks. As once we start the problems, I will be telling this formula we are using, that equation we are using. Don't ask, especially Bhavana. Bhavana and one more girl I forgot. You both are the ones who always ask doubt. Why sir this one? Why sir that one? Okay, asking doubt is good, but you ask doubt of the formula. Why you are using that formula? Because you have not learned the formulas and so on. So please take this as a personal advice, as a strong recommendation also. Brush up all those concepts and come. At least by Monday, should be thorough with the entire theory of straight lines. Of course, it is injustice from my part to learn everything within 1 day. So only I am giving till Monday time. However, you have to prepare for your weekend test also. Prepare entire theory. So learn all the formulas. Best thing is to learn is to write. Right? I want to start practicing the questions, write the formula for every time. So only I write a formula every time. Even though I know the formula, I write every time because it's indirectly I'm forcing you to write it. Without your conscience, your brain will grasp pattern. So lot of things you have learned, lot of formulas, lot of theorems, lot of formulas are there. Please learn all those things by heart. More than that, understand. Without those things, we can't solve the problems. Because some problems I'll be using directly. Let us say the formula, let us say I'll be using is for c square by AB, 2AB. You may ask why is this c square by 2AB? Because this is the area of triangle. Normally, I may use a equation. Let us say a square plus b square into lx plus my plus n, that is equal to 2la plus mb into ax plus by plus c. You may ask why is this equation? Because the equation for a perpendicular line image. Suddenly I will use equation ax1 plus by1 plus c by root of a square plus b square plus c square into ax2 plus by2 plus root of a2 square b square modulus point of intersection of two lines. So you should be thorough with all those formulas. Tuck. That's what you have to do. So we'll stop it here. So tomorrow when you come for the class, please go through the concepts of whatever we told, especially the centers of triangle. Once that is done, centers of triangle, a lot of formulas are there. Some formulas are very big. But if you learn those formulas, you can solve the problem in 1 minute. Not wasting much time and so on. So please learn the basics of centers of triangle. Tomorrow we'll learn some important formulas on that one. Then, if there's time, we'll start the problems from tomorrow itself. We'll start from Saturday. So thank you, dear students. We'll meet. Kindly start revising whatever you studied. As part of a weekend exam also, and part of solving problems. Thank you, sir.
Thank you, sir. Students, you have class again tomorrow at morning 5 o'clock. Thank you all.